give us the opening prayer. Thereafter, we'll start our session. Okay, Faith, you can go on.
Okay, we shall all pray. Father, in the name of Jesus, thank you for your power. We thank you that it's like you. In Jesus, we thank you that you are from school, Father, and as we start on our lessons, Father, come amid us, ask Jesus that we must partake whatever we are going to raise. Bless our teachers, Father. Bless us in all that we do, because you are God and you're God alone, Father. We live in you. In Jesus' name I pray. Amen.
Amen. Thank you so much, Amy, and for that very wonderful prayer. And let's type amen in the chat to believe in that prayer. And I want to welcome you again to this mathematics session. And as a trend, we always open with an opening prayer. And that one was from Faith. And I must say she has given a very wonderful prayer. We will be interacting in mathematics, and it's going to be a revision session for mathematics. So I pray that we're a little bit attentive. I'm in a place where I can't guarantee whether I'll be very audible, but struggle so much to make sure you hear and we have a successful lesson. I want to welcome you from whichever school you went for your lessons. And I want to tell you that where we were, we successfully concluded our term 1, and I will hope you too concluded your terms very well from wherever you were. And yes, we are here now. I will suggest that we close our microphones. Faith, maybe you will help me in the background to see if we have almost everyone closed. Sorry, I had already alone posted this preview of the lesson on the WhatsApp platform. And if you received it, it was a video and an assignment to try to trigger your mind to what we are going to look at this afternoon. And you'll allow me start from there. And I saw some students had posted their findings on WhatsApp. Later on, probably we will make a reference to it. I want to welcome you again. And my name is Masawa Erisa. I work with Bali Secondary School. I also work with the Holistic E-Learning Platform. I handle mathematics and ICT. So we are always here to help you. In most cases, we are here to give you a feel of how next term will look like in the respective schools you're going to. So allow me start by taking you through what we expect next term in your schools or in the school where I teach. You're going to be going to term 2, and these are the chapters we expect you to handle this term if your school moved very fast. This term you were expected to have covered the equations of the straight line. For those who are still covering book 2, then I really don't know, but by now I expect that almost every school has tried to see what is happening in book 3. And we expect your schools to have taken you through equations of the line. And in the equations of the line, you do simple things like getting the gradient of the straight line and writing the equations of the straight line. And we also expect you to learn how to work with perpendicular lines and parallel lines. And the trick when it comes to parallel lines is that they have the same gradient. And if they give you 2 lines and they want to confirm if they are parallel, then you try to show that the gradient in both lines is the same. Then for perpendicular, something like that. And also we expect to have entered in trigonometry. And in trigonometry, we expect you to see how to apply the Pythagoras theorem in getting the sides of the triangle, and thereafter get the angle that is formed by the two lines. So, and also data collection and display, where you were supposed to have been taken through how to collect data and use maybe frequency tables to come up with the analysis of such data. And that data can maybe be students' marks in a given class, such that you try to get the mean, maybe get the mean, and also draw those charts. Then we'll be trying to review vectors. I know this is the last topic in term 1. Maybe in your school they did not cover, but if in your school they covered, then we are going to revise. So we'll be talking about vectors in this session, and vectors we're going to make in vectors, we're going to make reference to our senior 2 work that we covered in senior 2. For those who were here, we did something on vectors. So in senior 3, you're going to make reference to that, but then it goes deeper a little bit, where they talk about collinear. They will tell you the parallel vectors. If they're given you 2 vectors, how do you prove that they are parallel? So it's a bit deep, but it makes reference to what you studied in senior 2. And I'll assume you remember that. If you don't remember, we'll do a quick review in it, such that it's a walkover as well when you get back if they have not taught you. But if they have taught you, then it will help you master even better. Then in senior 3 term 2, we expect you to do ratios and proportionality, business arithmetics, business mathematics. That makes reference to the business arithmetics you studied in senior 2. Then trigonometry 2, matrices and matrix transformations. So a serious student, of course, I know all of us here are serious students. You take a screenshot of what is expected in term 2. And I will also display what is expected in term 3. In term 3, you will cover all this. Probably we'll also talk about that next term when you come back and we've covered term 2 content. So take a screenshot of what is expected in term 2. You don't need to sit in a physical classroom for you to learn these things here. Ratios and proportionality, you can download notes as you're in the holiday. Try to make simple notes. If you can request your parents to print for you, the better. Go and do this such that as term 2 ends, you've reached at least matrices. We expect you to come back in our lessons of holistic next holiday when you can handle matrices at least. So try to move through until maybe if you find a teacher to help you, ratios and proportionalities, the better. Business math, the better. In most schools, students have relaxed with the new curriculum, but in the times when we studied, by senior 3, a student was already self-driven. So I have given you the topics. You'll be self-driven, start to prepare notes about this. Where it is hard, go to a teacher and request the teacher to take you through. Otherwise, I want to welcome you to this session. Allow me to proceed to what we are going to talk about. And in this session, we are picking the last topic of first term, and that is vectors, and we're going to make revision about it. And these vectors we're going to talk about. At this juncture, I want feedback. I want to find out if I'm audible, because I'm trying to compete with rain here. Let me know if I'm audible. And okay, I also want to read about your schools, and probably I'll put my school here. Balices, I had read about someone from Balices earlier on. If I can read more from Balices or any other school, I will be very excited to know which schools you're coming from. Gasco, that is Rivoa. Teacher, you're clear. Yes, this is good now. If I am clear, I was worried. Mango Senior School, you're most welcome. And the Gasco has 2 people here, which is good enough. And Mango SS still is here. Gayaza School and Nansana. St. Joseph, correct? Seta is here, Igasco. Please, last 2 topics. Please, the last 2 topics. Okay, I will preview this. A person who is requesting for the last, can you take a screenshot of all that such that you don't ask you're so audible? Thank you. At least St. Catherine SS is also present here. St. Mary's College, you're also most welcome. Then Code High, I've never heard of the Code High School, but thank you for representing your school, Cynthia. Then we have Nambongo Secondary and Vocational School, Jotham J. You're welcome. Our Lady of Good Counsel, Beatrice, and Igasco. This is Melissa Kisa. You're all most welcome. So we'll be picking the last chapter, this one here, of term 1. Now, may I know from you the topics you've covered in term 1. If you see any topic you've covered in term 1 that has been displayed here, just type it in the chat. For example, you may have finished trigonometry 1 or data collection or even vectors. Just type the one you've covered in the chat here. If you've covered anything here, I want to see if people have covered. Sorry, I want to see the coverage at your school. Those 4 chapters. Mbale says, Samanya Trace, you're most welcome. Then we have equation of the line covered, vectors and data collection covered. That is Gasco. Good, thumbs up for Gasco. Vectors, data collection covered. Living Hope Christian High School, you're most welcome as well. Geometry and measures is a theme, so we can't know which one you've covered. That one is a theme. Vectors covered. Okay, that one gives us, we covered all. Someone is telling us we covered all. Praise Kelea. Good. Elizabeth tells us they have covered the equations of the line and data correction. Thumbs up for your school as well. Trigonometry, equations of the straight line, data collection, vectors, Igasco. Most welcome still. Igasco has covered this. Thumbs up for you. Sorry about that. Vectors covered Beatrice, that is good. Okay, we are going to pick vectors and we revise. So if you've covered, good for your school. If you've not covered, I'll try to talk about it here briefly. So vectors and vectors, probably, can we get someone to help us read for us the competency when we are talking about vectors? Then another person to prepare to read about the objectives of the lesson, which are the learning outcomes. So if someone is ready, I want to hear from someone if you're able to read that competency. Luboa,
yes,
Tracy, you can go on. Tracy, you can go on.
Okay. The competence says the learner understands the nature of vector quantities, manipulate, represent them, that solve problems.
All right, thank you so much, Tracy. And can we get the next person to read for us at least 2 of those learning objectives? If you're the first, you read A and B, and like that. Faith, do we have anyone?
Yes, we have Kenneth.
Okay, Kenneth, you can go on.
Describe the position as the vectors view. The vector line segment.
Sorry, we can't hear you very well. Faith, you can pick for me another person because even me, I can't hear.
Let's hear from Connie. Connie?
Connie, you can go on.
I guess we lost her. Okay, Keith.
Find the position vector of the midpoint of a straight line, of a straight segment.
So I can't see your screen.
Yes?
I think my screen is on. If she's not able to see, probably the network problem from her side.
So I can now see your screen.
Okay, can you proceed? Someone was reading for us.
Well, they have all run away.
Okay, we can proceed. So basically, those are the learning objectives that we expect to. Kenneth had a poor network, probably if he stabilizes, and we'll give them. So what we expect in senior 3 when it comes to vectors, a student is able to describe position vectors geometrically and as column vectors. Then you find the vector of a directed line segment. This one is picked from senior 2. Then find the position vector of the midpoint of the line segment. That is what we expect as well. Then use vector method to divide the line proportionately, internally and externally. And this one will also be described further on when we get into vectors. And in this section here, we will introduce in new Greek letters that some people could be hearing for the first time. And these letters, maybe the one I love working with most looks like that. We'll get to know which letter is that. And in some books, they maintain A and B, those letters, but the Greek letters are good enough. There's another one like this. We'll also get to know what all those Greek letters mean. So I don't want to take a lot of time on these learning objectives. I want straight away to go to the review of vectors. Now, this one is too detailed, but I expect to move through very fast. I may not involve so much here. I'm going to be reading through about this, what you should remember about vectors. The first thing about vectors in our senior 2, we talked about the definition of vectors, and we say the vector has both magnitude and direction. And for those who did the activity, you must have appreciated this very well, because the activity was talking about you define a vector. At some point, you distinguish it from what a scalar means. Then number 2 in the preview is that if you're given a position vector OP, if you're given a coordinate P that has coordinates, if you're given a point P and it has coordinates X and Y, and if you want to write it in a vector form, is called the position vector, and we write it as OP. So you change from writing it as a coordinate and you write it as position vector in a column format like this. We saw this in senior 2. And when you're given a vector which is looking like this, they may want you to get the distance between that vector, and the distance is called the magnitude, and that distance is generated from the Pythagoras theorem, and the Pythagoras theorem tells us that we square and we get it like this. So the magnitude is given like this. The magnitude sometimes refers to the length of that vector, and some books refer to it as the modulus of the vector. And it is denoted by, you write that position vector and you put it into two lines. These lines try to show us that you're trying to talk about the position of a vector. For example, if I am getting the magnitude of the line of the position vector or of the position vector of A, then I will put it in those two line segments to show that I'm getting the distance between those two. So the other one is to add two vectors. Now, adding two vectors, still it's very important for you to know that. I can't demonstrate that because it is a bit obvious. They can give you add vector A to vector B. So what I can encourage you here is that you maintain the positions. If A has 2 points, X and Y, and you've written them in column format, then you maintain where there is X, maintain, don't interchange them instead. Then, if for B also has X and Y, also maintain such that when you're adding, the X values are added separately and the Y values are added separately. Even when you're subtracting, you still do the same. Then subtract still is the same. Then a scalar is any value that multiplies the position vector, and it can always be factorized out. For example, you can see a K here. It's called the scalar multiple, and it is always there. For example, you can have, they can tell you in section A, when they are asking you, then they multiply 2 times OB, and maybe they are given you OB as maybe 3, 5. So they are multiplying this column vector with 2. So this 2 becomes a scalar and can always be written like this, 2, 3, 5, like that. Or you can even enter the 2 inside to give you 6 and 10. So we'll also see the application of this, especially when it comes to when you're proving that it is collinear. It is very helpful at that point as we go ahead. Maybe someone has never seen how they add vectors. I'll just quickly add 2 of them here. You may have 2, 3 as the first vector, and we are adding it to maybe 4, 7 like this. So how do you add? The ones up are added because they are representing the X coordinates in vertical form. So when you're adding, you get 2 plus 4 and 3 plus 7, like that. So this gives us 6 and 10, like that. So you would have successfully added these vectors together. When it comes to subtraction, you also just remove that plus and subtract, use the same procedure and get there. So that is what you may need to know when it comes to vector. It's called vector algebra: addition, subtraction, and at some point, multiplication as well. 6, then when it comes to 7, displacement, and here we are trying to say a vector. A displacement vector AB is represented by a directed line segment AB as shown. So if we are writing AB like this, if we have showed here displacement like this AB, this vector is written as A, B, because you're maintaining the direction. They're telling us that it is moving from point A to point B. So some books even put that bar above such that it gives you the direction of where that line segment of the vector is going. It's displacement in vectors. So some students, to them, it is easier to see that this is the same as BA. You can write as AB, but a student, for him or her, can see it as BA, and this is wrong. This one means that you're moving in the negative direction, you're moving in the opposite direction, and these two can never be equal. So if you want to make them equal, then you have to write it like this. AB, this vector AB is the same as the negative side of BA. Otherwise, the two can never be the same. But when you come to algebra, this distance is the same. The distance is the same, but what makes it different is that the other one is in the negative direction and this one is in the positive direction. So that arrow is very important to show you the direction of your vector. So probably I'll have to proceed. There are about 10 of them in the review. Yes, they're a bit many, and I may not talk about all of them, but this 8th one is very, very important, and we're going to make use of this 8th one when it comes to our revision, especially for those who did the assignment. You realize that you needed this knowledge so much. Maybe, can I get one person to read for us what 8 has, and if possible, to explain what it means? Someone can put up their hand. It's very good practice for you to see if your phone or laptop is working by putting up the hand and probably saying a word or two. So put up the hand and just read. If you can't explain it, just put up the hand and read. We'll get another person to explain it. Cynthia, you can go on.
In the triangle OAB, the displacement OA followed by AB is equal to single displacement OB. Number 9, if vector AB is parallel to CD, then AB is equal to KCD. Number 10, if ABCD is parallelogram, then the two opposite sides are parallel and also equal in length. AB is equal to DC and AD is equal to BC. Number 11, if AB is parallel to BC with a common point B, then the points A, B, and C are what?
Collinear. Now that should be a new term. It's collinear.
Yeah, collinear.
Yes, the term is collinear. Thank you, Cynthia. But we may not so much concentrate down here on 9, 10, and 11 because of time. We need to go and review what people came up in the assignment that was given. Now, I want us to concentrate on item number 8 here. Number 8 is telling us that the vector given is O. We will have O, we have A, we have B. And yes, Ruth, I have seen your hand up. Is there anything? Ruth? All right, so I'll be talking about this triangle because then it's the one that is going to help us so much in our next interactions in the next slide. And I was trying to explain something about this. Yes, you can go on, Ruth.
You had asked someone to explain what number 8 is.
Yes, you can go on, Ruth. You can explain something about number 8. I am just not sure if maybe it is my phone, but it seems you're breaking a little bit.
Let me move how we had. About number 8 in the triangle OAB, the displacement OA followed by AB is equal to a single displacement OB. When we talk about that triangle having a displacement of OA and then followed by AB and its single displacement OB, we are looking at finding the column vector of a free vector by using the position vectors of the starting and ending point. When we talk about a free vector, we mean all vectors whose starting points are not the origin. The position vectors, usually when we talk about position vectors, we have OB as seen, and then OA. OB and OA are position vectors. Any number or any vector that has its origin O. As if we have a the very
What is happening?
Let's give her a chance and we see if she can get clear. Ruth, you're breaking a little bit, but at least the point has been taken. I don't know if you can get a better place such that you can continue and give us that better explanation about the two position vectors, OA and OB. But for now, we seem to have lost you. So she was trying to explain for us number 8. Probably if there is any other person who can try to take it up from where she had stopped, you can go on. If not, we'll then try to talk about it from this other side. Ruth, are you still on? Ruth is off and it's very disappointing, and probably network is not stable that side. And she was trying to tell us something. Probably if she gets back, then she'll continue. Now we are trying to look at this vector triangle. It's a very good one in vectors. If you can understand this, then you're going to understand how vectors move. We have the origin here. We have the point B. We have the point A here. And they are telling us that if you want to get to OB, the position vector from here to there, they are telling us that there is a possibility of you moving like this, then move downward here like that. That's why we are having OA, and OA is moving up this other side. Then they are adding AB, which is moving downward this other side to give you this other one, which I can probably use green to give us this position vector B to get to B. Then you'll have to move up, which is OA, then downward, which is AB. And they are going ahead and making AB the subject of the formula by maybe leaving this one, this other side, and they're taking OA, the other side. And you can see that OA has gone the other side to make AB the subject of this formula. And there is this very important statement here. Now, this statement is going to be used so much in the next coming examples. I pray that there. Okay, I thought something was in the chat, but we'll have to continue probably for now. So in the assignment, I had given you a certain video to watch and try to use it to make probably some findings about your assignment that was given. And right now, I expect hands to hear from you people what you got in the assignment. If they asked you to distinguish between a vector and a scalar quantity, what would be your best submission? You just put up the hand and give us that. If you found out the difference between a vector and a scalar. In revision, we are starting with the differentiation between a vector and a scalar. Then in the same question, we are going to give some examples of a vector and a scalar quantity. Can I have Chirabo, that is Gayaza School, if I'm not mistaken. Chirabo, you can go on.
According to my findings, a vector is a quantity with both direction and magnitude, while a scalar is a quantity with magnitude only.
Okay. Can we get another person to challenge what she got, if there is any person? But then she has tried to give us the real difference between a vector and a scalar. And when you're distinguishing between those two, then you can't avoid to talk about magnitude and direction. So she has given us her finding. Is there any other person who wants to supplement? Thank you, Chirabo. This is who? Techno, K86. You can go. Techno. Okay, a person is using Techno K86. Your hand is up, but we can't hear anything from you. Probably we will have to skip that, and we talk about the examples. Give us the two examples, three actually, for a vector and for a scalar. So what we'll be doing here is you'll put up the hand, and if you're giving us the first, then you give us the first two. If you're giving us anything, then you get ready to talk about two of them. Put here, put the other side. I'm going to be this side to type them down. We see, I am seeing an hand up, probably from Chirabo still. I want to know who is using Techno. Who is using Techno? Someone is using Techno K86, or else we are going to put down your hand and we request that you don't put it up again, because we can't call you by name and you're not responding. Now, Kenneth, your network is not so good, but let me give you another chance to try out and see. Kenneth, you can go on. Which one did you find out?
For the vector, an example, we have force, weight, and velocity.
Force, weight, and velocity. Force, weight. And for you, you've given us all. I wanted at least one. Anyway, let me. Kenneth, are you still on? Vector this side, I have put force. Scalar this side, I put what? Kenneth, what can I put this other side? Yes, what can I put this other side of scalar? Okay. The what?
Volume.
Volume?
Yes.
Okay, we'll see if that is true later on. Thank you, Kenneth. Can I get the next hand? The next hand is coming from Probably Ngovi James, I've not heard from you. Ngovi James, you can go on. What do you have?
Okay, I have weight and mass.
Weight.
Then
Weight.
mass.
Mass, this other side.
Yeah.
Weight and mass that side. Okay, we'll talk about them later. Thank you, James. Then Kelea, praise, what do you have?
We have velocity and time.
Velocity and what?
Time.
And what?
Time.
I've not heard that.
Time.
Time, yes. Velocity and time. Okay. Where can I put again? I'm going to use blue to give the next answers. Still have your hands up. Patience, Naomi. What do you have?
On the side of vector, I have acceleration, and on the side of scalar, I have temperature.
Hello. Then this other side, you have what?
I have temperature.
Temperature. That was praise career, if I'm not mistaken. Then we have someone using Techno Power 3 air. You can go on.
Okay, from the side of vector, we have displacement, and from scalar, we have pressure.
What is your name, probably?
My name is Mystica.
Is who?
Mystica from St. Catherine.
I'm not heard the name.
Mystica.
Mystica. Okay.
Yeah, from St. Catherine.
Mystica, you'll check that spelling and see if that's the right name. Mystica was trying to name. You were telling us that you have what? Displacement?
Displacement from vector side and pressure from scalar.
Displacement and pressure. And scalar, this other side. Then who else has something here? Someone is using you. There is you, just you.
This
Displacement of what?
we said momentum, then speed.
Momentum and speed.
Then speed.
Momentum and speed. Like that. I think we've put almost everyone's answer here. We need to talk about these answers. Which one are we leaving this side? And which one are we discarding? We are going to start with force. Can I see people seconding force? How are we going to vote even? Is force a vector? Let's put yes in the chat or no. For those voting for force, especially if you want to distinguish this, you may need the formula for force in physics. I'm not seeing yes, I'm not seeing no in the chat. I'm only seeing one yes. People don't know. Yeah, I've seen one no. I think the yes is marked here. I wanted to check if people know what a vector is, but it seems people did not revise about what a vector is. Force is correct. Then I'm talking about weight. Weight, is weight correct or not? Now this one, we may need to debate. For weight, we may need to debate. Can someone try to tell us why weight becomes correct? Who is telling us? You think Alice is like, you want to say something?
I think weight is correct. Vector is supposed to have magnitude and direction. Force has the magnitude. Then as for direction, because it is a product of force and not force. Mass and acceleration due to gravity. The gravity is a downward direction force, so it has a direction.
We're talking about weight. Was that weight?
Yes.
Okay. Because of the gravitational pull that is downward. Anyway, what I can talk about a vector and scalar, like Chirabo said, the other one has both magnitude and direction, and the other one is just magnitude. And the best example I can give you is probably you sort out yourselves when it comes to selecting which one is scalar and which one is vector. After this, I'm going to assume this is my surface, and if we are using maybe for lack of a better shape, I'm going to call this a stone. And if this is a stone and it is at a point A, and you move it to this other side, I don't want to say I am maybe reflecting it. For those who may recall their senior work and call this reflection, I have moved it to this position A. I mean to this position B, and I'm going to just borrow that knowledge of reflection such that you know that it has moved from here up to this side. And maybe if this was position A, like that, and it has moved to this other side, 5 meters, 5 meters like that, then you realize that if I told you that this stone has been moved from here to this other side, 5 meters away from this other side, so meter becomes the distance it has moved, but I've not added the direction. And when I don't add the direction, if I tell you without this sketch, you may even move it this other side, still 5 meters. I mean 5 meters this other side. And because of that, Alice, is that hand still up or you forgot it? Okay, so because of that, I've not given you direction. You can choose to take it any side. But when I tell you that 5 meters, now this is to the right, then this one becomes a vector. So when I give you the distance and I also attach the direction in most cases is what we refer to as a vector. It must have the magnitude is the distance between the two, and it should also have direction. And the best example there is probably, I don't know, the force could be one of them, the better one, and the team here was trying to bring in the physics bit of weight when it comes to the gravitational pull that pushes the thing down. So basically, I expected you to have gone through this difference between a vector and a scalar, and you've written something. I read about people's work on the platform, and we'll collect it slowly and we compile it into one PDF, and we put a mark where there is a mark, and we'll put a cross where we feel you did not explain well. So I'm going to put off this vector and scalar, and probably, is there any other person who wants to say something about a vector and a scalar? This is more of physics. That's why I want to avoid it for now, and we go so much into the mathematics, the mathematical bit of it, for not wanting to scare people away from here. Is there something a person would want to add when it comes to scalar and vector before I put off this exam completely? Okay, so what, like I told you, I'm going to leave out. Yes, Kenneth has confirmed no one wants to say something here. This is so much into the physics bit, but if you made the research, put it in WhatsApp such that I would look at it and see whether you got the right thing or you researched wrongly about the two differences. Allow me go a little into the mathematics bit of vectors. And the mathematical bit of vectors, in most cases, we deal with position vectors. How do you convert something if it is given in coordinate form to a column form? I had told you in the introduction that always reserve the x coordinates and reserve the y coordinates as well. So when you're changing it from this other coordinate bit, which is x and y, and you're putting it in the vertical format, we call that you're getting the position of that coordinate. For example, if it's coordinate A and you want to write it into vector format, then you're getting the position vector for that A. And when you're writing it, always maintain 4 to be up and 1 to go down. It's a little obvious because we looked at that so much in vector algebra 1. So in this example, they want you to get a column vector AB, and the column vector AB is got, what I can encourage you people here is to always sketch. I'm going to start by sketching such that I give you a feel of what we expect you to do when it comes to such items. I'm going to make a black background here such that I can annotate. Now, whenever you're given such problems in vectors, it is a good practice for you to sketch them down to give an examiner a feel of what you feel was being referred to. And I'm going to assume this is my X and Y axis. Now, we have a 16, so I'll put it a little bit down. This is our X and Y axis. And I'm going to assume I'm plotting my point A. Point A is 4, 1. So I will assume 4 is somewhere here. 4, 1, sorry. And if maybe this is 1, I will assume this is my point A. It's good practice for you to sketch. You may not draw a real axis, but at least sketch something to show that you've plotted the point A1 and B. B is somewhere here. and B is 12 on the x-axis, and we have 16 on the y-axis. 16 is this other side. 16 is this other side. I think I can put it somewhere here. And we're going to call this B, which is 12, 16. It doesn't need to be too accurate. Now, this sketch already shows that you know what you're doing. And like I told you, we work for maths at some point. If you're trying to come up with something like this, you give the teacher a feel of who they are marking. But if you just straight away start quoting the Pythagoras theorem and say, I'm now getting this, I have to put this under root. Yes, we will know that you've understood how to get the length of that vector, but then we may not know that you've also applied the knowledge of plotting that you studied in senior 1. So this one can give you a mark for sketching. Always these questions go for 5 marks in section A. Sometimes they go for 4. So look for all ways of getting all the marks. There is that hand up. Jerry Watts? Jerry Watts, your hand is up. Okay, Jerry Watts, I will try to assume you forgot your hand up. Now, every time they want you to get a column vector for AB, this red line is the one that is AB. A vector is the shortest distance always between 2 points. You can see this point A and this point B, and the shortest distance is only this straight line here. There is no any other shortest distance that can take you from A to B apart from this red line. Just that mine is not very straight. But the only shortest distance is that line there. So they want you to get a column vector, and the column vector will bring in the displacement, which is knowledge that was in translation vector, if you remember that in your vector algebra 1. So in other words, they want you to move this vector downward like this. Then you also move it upward. This is the horizontal and vertical displacement of that vector. And how do you get here? If they have given you 2 points and they want you to get this vector AB, how do you get there? At least get to know the following. The displacement always is in the horizontal sense and in the vertical sense. And the difference here, you can get this 12 and subtract 4 to give us what? When you subtract, I'm trying to get this distance down. That is what? 12 minus 4 is what?
8.
That is 8. And then this one is 16. I'm now looking at this other side, 16 minus 1 to give us, I think, 15. So this vector AB, yes, this vector AB is equal to the horizontal displacement, which is 8, and the vertical displacement, which is 15. And that is the position vector you are requested to get. So that is so the vector AB is always that displacement, the horizontal and the vertical. And how do you get that? The formula is always given, but I was trying to show you that you may not necessarily do this every time you asked to get the vector AB. And the vector AB is always, you move from, I don't want to explain it that way, but then the formula is always AB. The formula is always OB. You take away OA, and these are position vectors. OB, like I told you, the coordinate bit of B is this one, 12, 16. And if you want to write it in coordinate form, I mean in vector form, then it has to be written. You maintain the X up, then the 16 will always be down. Then you take away the position vector of OA, which is what? OA is going to be 4, is going to be 4, 4, 1. And then that difference, the difference you get here is the one I was trying to explain down here, 12 minus 4, which is 8. And the other one is going to be 15, like that. So normally, the formula is always given, and it is good practice for you to always use this formula when you're given any question that involves getting the position vector, I mean the vector AB, and sometimes yeah. Okay, I was trying to check something here. Sometimes you can be given AB, and sometimes you can be given CD, like this. There is a vector C and this one, and that formula now becomes OD. Take away OC, like that. And if you're given AB, then you get the position vector OB. Take away OA. If you're given maybe TK, we are going to see all those letters come up the other side. And what is here is that you maintain the last point, which is K, and you get that position vector, which is the last, and take away the first, which is OT, like that. So probably that is what I felt you need to know in that question number 2, when it comes to getting the column vector AB, and it is mathematically got from this other side, and this 8 and 15, for those who remember translations, then you will appreciate this more. So maybe I'll clean this to give chance to those who researched to let us know what they found out for question number 2. And that will be by show of hands. You just put up the hand, let us know what you have. If possible, you can annotate on the screen and give us your finding as the person who did number 3 prepares, number 4 prepares, like that, like that. Let me know if someone is ready. I saw Praise's hand up. Praise, you can go on.
Excuse me, sir. I have a consult. I want to consult from you. But after these lessons, are they actually recorded like in a video form?
Yes, they are recorded always.
How can I get one for today's lesson?
One for today or yesterday?
Today.
Now, the lessons for today start at 2 and end at 4. So you can only get the recording after 4 when the lesson has ended, and the recordings are always posted in the WhatsApp group.
All right, thank you, sir.
And also we have the Holistic E-Learning Platform YouTube channel where we always post them. If you can't find them in the WhatsApp group, then you can go to the platform on the YouTube. You can get it from the YouTube channel. You just put in the holistic learning platform on YouTube and they'll give you the lists of those lessons. You try and see if you can get it from there as well. I want to find out those who researched about number 2. I'm going to leave that screen open for you to annotate if you can. If you can't, then I will annotate from this other side. We want to get the column vector AB and also its length. I want to hear from Sharon Oprah. Your hand is now down. Did I see it up? Sharon, are you still there?
Yes, sir.
You can go on. Are you going to annotate or I will have to write for you from this side?
Okay, you can write for me.
Okay. What do I write?
It is A squared plus B squared is equals to C squared.
Hold on. It is what?
A squared plus B squared is equals to C squared. Is equals to C squared. 8 squared plus 15 squared is equals to C squared. Eight squared is equals to 64, then plus 15 squared is equals to 225.
200 and what?
25 is equals to C squared.
Yes.
It is now 289 is equals to C squared. You find the square root of 285, which is 17, and the square root of C squared is equals to C. So C is equals to 17. But it is either positive or negative 70.
So C becomes
17.
17. Yeah, so she has got for us that length of the column vector AB, and she has got it as 17. I wanted you to start from Roman number 1, but maybe you assumed we already knew that. Can we get, thank you, Oprah. Is there any other person who wants to supplement something here? Kenneth, your hand is already up.
Sir, I was inquiring, don't we put units?
Don't we put units? Now,
yes, teacher.
This is the magnitude of a vector. That's why I was a bit silent when she mentioned either plus or negative. And we are getting the distance between the two. And in most cases, this distance is given in the question, if it is there. And if it's not there, then you just leave it in units because we don't know the units to put here. I don't know if that one answers you.
Yes, teacher.
Right? But then the magnitude, for those who have tried out, this is Pythagoras theorem, and it is helping us. She's trying to relate. She's trying to relate. I have put off my graph, but she's trying to relate this vector AB, which was looking like this. Maybe I need to draw a better one. I put off my graph, but it had something like this. The vector, sorry, this is even a worse color. Probably I can pick red. There was our vector AB was looking like this. AB was looking like that. And she wanted to get the displacement. And she knew very well this was what? 8. And this was 15, representing that vector. The shortest distance is here, AB straight away. And if you want to move the horizontal displacement, then the vertical displacement is 8 and 15. And we know how to get that from Roman number 1. And she wanted to get this, and she called this C. So she called this A, B, and see the other side. And she was borrowing the knowledge of for Pythagoras theorem. That's why she stated that when you get a squared and add b squared, the answer is always c squared. So in your, I don't see any hand up. It means no one is questioning this, even when I expected some hands to come up. But instead, I'm not seeing any hand here. Probably I will assume that maybe that was okay. So what I can, because I want to polish up this such that when we get to number 3 up to the last one, no many questions comes up. So for such questions, if you're given such a question, always find AB, which we got very well, that column vector AB, which was 8 and 15, like this. Then if they want you to get the length of a vector is denoted by AB like that. And always, whenever you have this and that, this one represents X. This one represents X, the first one, and this one represents Y. So, sorry, I'm failing to write Y. So if you want to get the distance between that vector, the magnitude, which is called the magnitude, the formula is you square X, then you add Y squared like that. For those who watched that video, you must have seen how this was got from first principles, and this was explained in our earlier lessons of vectors in senior 2. I don't want to take us back to the graph again, X squared plus Y squared, but it comes from this Pythagoras theorem, but it is not a good practice for you to quote the Pythagoras theorem straight away. That's why I've circled it here, not that it is not correct. So every time you're putting up the hand, I want you to relate to this. So I will expect you to write that the distance between this point or the magnitude of that is equal to X squared plus Y squared like that. Then you tell me that my X value is 8 and my Y value is 15. Like that. So that will be 8 plus 15 to give us, sorry, this is squared, like that. And this is 8 squared, where she got all that. And this becomes 289 under root to give us our answer as 17, like that. So there are so many questions that are always set like this. Maybe because we are talking about it, I can make use of another example here. You may be given values, maybe as maybe PM. They want you to get the distance PM and the distance of PM, which is the magnitude of PM. And they have told you that the point PM is 2, 3 for P, and for M is maybe 6, 7, like that. So how do you get this distance between the distance of P and M, which is called the magnitude of PM? How do you get that? You need to get PM itself. And PM itself is that displacement, and this is a translation. If you sketch this on a graph, and it's a good practice for you to then write the formula as the position vector OM, take away the position vector OP, and this position vector OM is this one here, but in column vector, in column format, which is like this. You maintain, don't interchange 7 to go up and 6 comes down. So we expect you to do that. Hey, same one you're trying to write here. If I confirm that it was not a mistake, you'll see yourself out. So I'm trying to get PM, then I go ahead and put my PM in this formula. So this will be 6 minus 2 to give me 4, and 7 minus 3 to give me 7 minus 3 is what? I think 4 still, like that. So my PM, the displacement or the column vector, PM is 4, 4, like that. Then my first 4 becomes the X, this becomes X, and this becomes Y, like that. So patience, don't write that, don't write there, you're also starting to write. Maybe you're practicing for the next question, which is okay, but you wait when you're given a chance. So PM, our column vector PM was 4, 4, like that. And if they want you to get the magnitude of PM, it's a good practice for you to put it in those columns. And this one is read as the magnitude of PM, the magnitude of the column vector PM, like that, or the length of PM, or the distance PM, the distance between the 2 points P and M. Some books refer to it as that. So I'll put this under root, and this will be 4 squared plus 4 squared to give me 16 plus 16. And you proceed and you get your answer. So you would have got the distance, you would have got the magnitude, you would have got the modulus, you would have got I want to discourage going straight away to just get those answers without having to use a formula that is related to that. So I'll end there. If there is any question here, because the next session is going to be student-centered, you put up your hand and do the question. I've already put these questions on WhatsApp. If you've not understood something here, put up your hand. Let me talk about it before we enter into the student session. And if there is no hand, uh, 15 times 15. This is 15 times 15. Someone has corrected. 15 times 15. Yeah, that was a good one. I've not noticed that. This was 15 squared, like that. Thank you. That was Oprah. Is there anything I need to talk about here before we go to the next question? Bide says no, probably we can now continue. So the next question was number 3, and they want us to get the magnitude of PQ. So for you to get the magnitude of PQ, you must get the column vector for PQ, and I'm going to give chance to Chiravo, Anna, Paul to take us through that. Chiravo, may I confirm if you're able to annotate, or I will do it for you from this side?
Actually, I do not know how to annotate.
Oh, you give it a try. Are you able to see a pencil?
No.
You're using a computer or a phone? I mean, a laptop or a phone?
Laptop.
It's fine. Eh? You can go on.
Okay. I started with getting the column vector Q, which is OQ minus OP.
Yes.
Which will be 4, 5 in column form. Negative 2, 13. Which will give 6, negative 8. And then for the distance, PQ is equal to the square root of x squared plus y squared.
So about that, you can continue. Is equals square root of
X squared plus y squared. Which will give you the square root of 6 squared plus 8 squared. And that is equal to the square root of 36 plus 64. Which will give you the square root of 100, which is 10. So PQ is equal to 10.
PQ is equal to 10. I think there is no problem with this. If there is any person with an inquiry or a supplementation, let us know. Chirabo, thank you. That was, I think, a good one. Tracy, your hand is up.
For me, I'm not understanding how the -8 became a positive.
How the -8 became a positive? By the way, there is that. Chirabo, you can talk about that. Shirava, are you still there? Or anyone can tell us why the -8 has become a positive?
I can't explain how.
Yes. You did what?
I can't explain.
Oh, sorry, I didn't hear that. Who can help her? Why has -8 become a positive? There are so many hands. I want to hear from maybe Samanya Tracy.
It's because a negative
What do you
times
have?
a negative. So it's because a negative times the negatives gives you a positive.
Where exactly?
It's -8 times -8, giving us 64.
-8. Okay, I've seen that.
Yeah.
But then it's asking, why is this not positive? Why is this not -8? Instead,
It's because the negative times the negatives gives you a positive.
Okay, yeah, because there was a negative squared and the negative was multiplying itself. That's why it maybe didn't appear. Let me hear from someone else. Thank you, Tracy. Kenneth, what can you have there?
So I have the same suggestion.
That what?
So I think when you multiply positive times a positive, you get positive. Then the same thing will be for the negative side. When you multiply negative times a negative, you get positive. So it's okay. We write positive.
All right, thank you so much, Kenneth. And he's also explaining the same thing what Tracy Samanya said. And maybe to also add something is that our formula is x squared plus y squared. And when you put a negative in this y here, -8, it becomes positive straight away. But it is not a good practice to ignore that negative. So I don't recall who asked that question, but it's a good question. So it's good. She needed to have written as -8 squared like that, -8 squared, to show that where there is y, we are replacing it with -8. And of course, because it is squared, then the negative at that point disappears, because a negative times a negative becomes a positive. So this becomes 8 squared, like Tracy was saying, and also what Kenneth has tried to emphasize. So that is how that negative disappears, because it is squared in the formula. Yes, Hannah Shirago.
I have a question. For example, when you have 4, 4 as your column vector, and that will give you 4 squared plus 4 squared, which is 16 plus 16, which is 32. That one does not have an exact square root.
Hold on. You said maybe, for example, 4, 4. 4, 4, which will be the square root of 16 plus 16.
Plus 16, which will give you 32.
To give us what? 32 squared. Yes, here you write it in a SAD format. I don't know if you know how to express it in a SAD format. Alternatively, you can put this directly in the calculator and it gives you. So here, this is 4 times what? To get 32, you multiply 4 times what? Is it possible even?
It is 16 times 2.
16 times what? Let me see. I need to express that. Not 16 cannot give us, but there you just put in the calculator, but you maintain it to 4 decimal places.
So would it be advisable to leave it like that?
No, there you would have not finished. You would have not got the answer. You are still working.
Okay, sure, thank you.
This is the same as 4 times 8 under root like this. But 4 under root is 2 root 8. So you can read, you can write it in like that. This is you've written it in a SAD format, 2 root 8. This one is also correct. This is actually the most correct. But if you get it under root, let me see what that answer is. That is root of 32. That is 5.65. Something like that. So if you can get something like that, it is good. Can I get next person to take us through? The other one. If there is no question. I will clean this. The next question is number 4, and it's here. I want you to get the distance between this and that. Yes, we can. Can I have Kenneth go on?
Yes, teacher. So
yes, you can
to find the distance, teacher, to find the distance between point P and Q, we have to first find the column vector PQ. In doing so, we are going to subtract OQ minus OP.
Will you manage to annotate?
No, teacher.
Okay, what do I do then? Tell me what to do.
Teacher, to find the distance between P and Q, we need to first find the column vector PQ.
Oh, PQ.
So
What
teacher, we are going to first.
Yes, please, you can go on.
So PQ is equal to OQ minus OP.
Yes, please.
Our column vector OP is equal to 4, 4, 7 minus into brackets -8 -8 2, giving us our column vector 12, 5. Then from our formula, we are going to state that PQ is equal to square root x squared plus y squared. So our x value is 12, and our y value is 5. So the square of 5, which is 25. We maintain.
So the total here is what?
The total is 169. It is 169, and the square
The square root is
13. So that's our distance.
So the distance is going to be equal to 13, like that. I think this one is okay. If you had that, then it was correct. Can I see if there is any hand? And if there is no hand, because of time, I'm going to leave the remaining such that we try. I'm in the place where I'm failing completely to concentrate. So I suggest that question 5, 6, and 7 up to the last one is posted in our WhatsApp group. I'm interested in the last question, which is number 12. Post it, the WhatsApp groups are open. I want to mark such that I bring back the marked scripts. Allow me to end this here because I can't just concentrate up here, and wish you a very good evening. And probably I see so many hands up. I don't know if you want to say something. Let me know. There is that Tracy. There is that hand up.
Yes, pardon, where we are sending the work.
We are going to send it on WhatsApp. Someone should send that link of the group if you have here, such that your friends can join.
Thank you.
We have so many questions here remaining up to number 12. There are so many of them here, but I can't concentrate up here. So allow me to end it here for now, such that we can concentrate on the remaining work. It is almost having the same task. And try it out, share the work on WhatsApp.